Now let's take a look at problem 28. In this problem, we are given a function. This function describes the concentration in the blood stream after some drug is injected. Here, this A is the units injected. T is the time. Now, there is a requirement here. The maximum safe concentration is 1 milligram per milliliter. In other words, we want to make sure that this function, the value is always less than or equal to 1, cannot be above 1. So the first question is to determine what this A is and when does this maximum occur. Now, first of all, I would like to type in my function. So without the A, by the way, this is x times e to the negative x over 3. Let me call it as h for now. I don't bother to type in my A for now because I would like you to experience just here. This is without A. I would like you to type in, say, 2 or 3 here to see the effect of the constant. So I'm going to type in 2 here. And if you compare to previous one, it's just the shape is about the same. The only difference is the scale, the vertical scale. So this value is basically just rescaling the function, the vertical scale, right? If I change back to 1, then this back to somewhere about 1. The maximum here, the value always occur at the same location. So we just need to figure out this and make sure that the maximum rescale it. So the maximum is just 1. So with that interpretation, we need to do two things. One, find where when the max occurs, right? We need to figure out this time. Once this time is figured out, and we plug this time into this function and make sure that the maximum value here will not pass 1. Let's say set the maximum to 1. Okay, how do we find this where the maximum occurs? Usually you do this. Set h prime to 0. That's how you find the critical value. So part of that. So when I compute the h prime, this is what I have. If you set to 0, and you see this is a common factor, right? E to the negative x over 3. So move it out, and you are left with 1 minus 1/3 of x equals 0. And you can easily see that when x is 3, this is critical point, and that's where the maximum occurs. Maximum value occurs at h3, right? So I compute h3, h3.0, okay, and which is equal to this guy. I'm sorry, let me compute h3, not h3.0, to get a precise number. So h3 is equal to 3 over e. Okay, so in other words, my h3, which is x times e to the negative 3 over 3, is equal to 3 over e. Now this is my h of x. I want to figure out an A so that this largest value is equal to 1 when x is equal to 3, when the time is 3. With that, A is equal to e over 3. Is that right? So that's how I find my h of x. So now, after the discussion, we do know, hey, this e must be e over 3, and this is the function that we have here. So this is the first part.